created the project and at least one drawing, the next step is modeling the structure. We will see how to start this process in this class, learning how to create a grid, which is a set of lines that will serve as a reference for the construction of the structure. Let's get started. With the previously created drawing opened, we access the Structure tab, and in the Parts panel we click on Grid. See the open window, where we will put the necessary information for creating the grid. We can also access this window by typing as shown. First we must name the grid, and in our case, we name it as Metal Structure. If multiple structures will be built, it is indicated to identify with easily recognizable names. In this field we opt for the coordinate system, and we have three options, which will define the orientation of the axis in the direction X, the line in the direction Y and the platform in the direction Z. The first option is the Global Coordinate System, WCS, which is defined by the program. Using this option it is always possible to return to X, Y and Z data, giving a good reference to our 3D environment. This is the option we will use in this course. The second is the User Coordinate System, UCS, which can be useful if you already have a Cartesian reference defined for the project. And the third option is to enter 3 points, where we determine the coordinate system, guiding one point in each direction X, Y and Z. In the boxes shown, we enter the values that determine the size of the grid and see that we have 3 current values, referring to the axis, the line and the platform. These values will set, respectively, the X, Y and Z directions of our grid. We can enter the values of the axis in 2 ways. The first is, in the value box of the axis, enter the desired values of X, separated by comma. The amount of rows this axis will have depends on the amount of values entered in this box. Using the @ character, we state that the value entered is relative to the previous one, that is, it is the value we are entering plus the previous value. For example, the values 0, 1000, 1500, 2000 are equivalent to 0, 1000, at 500, at 500. The second way is using the box shown, which returns to the drawing, where we inform the points where the lines of the axis will pass. These 2 forms of insertion are also available for the definition of lines in Y and platforms in Z. Follow the definition of the values in the respective boxes. We can still name the axes, lines, and platforms, and Plan 3D standardizes that. See. By clicking on the arrow shown next to each name box, the names are updated as we add values to the value boxes. We can also change the names manually as desired. In this case, be aware that the number of names is equivalent to the number of values. If we do not want the name of axes, platforms and lines to be shown, we delete the names of these boxes. We can also define the font size in which the name of axes, platforms and lines will be displayed. Finally, just click as shown to create the grid. See that it is built in the coordinate system that we choose, and the directions are presented with the names that we define for them. In order for this grid to be highlighted in the 3D environment, we can place it in a light-colored layer. Thus, if we need to turn off the visibility of this layer later, that is, hide the grid, this is possible. We finished this lesson, where we learn how to create a grid, which is a set of lines that we will use as a reference for the construction of the structure.